Today we are going to talk about factoring by grouping. This is going to be in your toolkit, so go ahead and pause the video, put the title in your table of contents, and you can copy down that first sentence with the highlighted vocabulary. Factoring by grouping is a strategy that can be used for trinomials, which we'll get to towards the end, but this is particularly useful for factoring polynomials with 4 terms. So anytime you have 4 terms, you now know that you have to use this method, which is called factoring by grouping. Please feel free to pause the video as we go through these examples to write down any steps or whatever it is that you need to do. I have these 4 steps written out. Normally I would have them typed out for you, but today you're going to have to write them down. Feel free to abbreviate as is necessary for yourself. And I'm going to go through these 4 steps with example number 1 slowly, and then we'll practice for the rest of the lesson. So when we have 4 terms, like number 1, x cubed plus 4x squared plus 2x plus 8, we can't just do it the way we've been doing it. So we are going to use what this method is called as grouping. So the first thing we're going to do is pull out a GCF, if possible, or a negative a value. Here, we do not have either a GCF or a negative a value, so for now, we can just skip that step. The next thing we're going to do is we're going to group terms with common factors. If you look at these first 2 terms, they have a common factor of x squared. And then if we look at our next 2 terms, and I am purposefully including the plus sign, we'll talk about that as we go, then these next 2 terms have a GCF as well of 2. So we're going to group those 2 terms. For these first couple problems, I do want you to draw those little kind of brackets so you can really visualize your 2 different groups that we're talking about. Step 3, factor out the GCF of each pair of terms. So like I mentioned, this first set of terms has a GCF of x squared. So I'm going to pull out x squared, and then we're going to write what is left. So x squared times x will give me x cubed. And x squared times 4x, x squared times 4 will give me 4x squared. So you can always check by redistributing in your head to make sure that what you have here will give you what you had there originally. All right, let me erase that. The next thing we're going to do is whatever this sign is here, it needs to come down in this next step. That's really important. Now, my next 2 terms had a GCF of 2, so I'm going to pull out that 2. I'm pulling out a positive 2. So positive 2 times x will give me that 2x that I had, and positive 2 times 4, positive 4, will give me the 8 that I had there. What we're going to notice now is that this binomial that we had matches. It is a common binomial. So now instead of having a common factor, we have a binomial in common, which is being multiplied by those other terms. So what we're going to do is we're going to factor out that common binomial. We're going to pull it out. And then what's left, the x squared and the 2, is going to be your other binomial in your answer. That's your answer. That's your factored form. And if you're ever unsure, you could go ahead and FOIL that out, use the distributive property, and your answer should match what you started with. Number 2, x squared plus 4y plus 2x plus 2xy. Now, the order that we have these in might be a little tricky, so what we can look at is we can try it. Don't write this down because we might need to change things. Hint, hint. If I group these 2 and group these 2, there is no common factor in these first 2 terms other than 1. So let's see, if I pull out a 1 and I pull out a 2x, these don't match. So that's a problem. If that happens, and if you can tell by looking at it ahead of time, you can rearrange your polynomial to make your life easier. So I'm going to rearrange this to be x squared, and I'm going to put the 2x next to it, because then I know that they'll have an x in common. Then I'm going to put my 2xy and my 4y. And sometimes this might take some trial and error. Now I'm going to group. They have a common factor of x. And now I'm going to group. They have a common factor of 2y. So let's see if this works. I'm going to pull out their x. X times x is x squared. x times positive 2 is 2x. Bring down the plus sign, again, super important. Their GCF is 2y. 2y times x will give me 2xy, and 2y times 2 will give me 4y. I have matching binomials, which is critical. You always have to have little twins there. Pull out your common binomial, and the other factors that were there go in your second binomial. They won't always be that tricky, but that's why I wanted to have that example in there. I'm going to work through 3 and 4. You can do them at your own pace as well. 3 and 4 should be less tricky than 2. 3 is b cubed minus 4b squared plus b minus 4. And I'm not going to rearrange these. I'm going to show you how to deal with something here where they don't have a visible, an obvious common factor. These first two terms have a b squared in common. So I'm going to pull out a b squared. B squared times b is b cubed. B squared times 4 is 4b squared. And then these next two terms, after I bring my plus sign down, the only thing they have in common is a 1. So I can pull that out. Sometimes it will work to just pull out a 1. And what's left is a b minus 4. My binomials match, so that's good news. B squared plus 1 and b squared minus 4. Now, I'm hoping that some of you are kind of perking up at this little binomial. It kind of looks like a dots, but it isn't. There are going to be some problems where what you factor out is still a special product, and then we're going to factor even more. It's like when we take out a GCF and then keep factoring. So start looking for some of those special products because they will come up very soon. Number 4, 12a cubed plus 2a squared minus 30a minus 5. These first two have a common factor of 2a squared. These next two, don't forget the negative there, this is important, are going to have a common factor of 5 or negative 5. The 2a squared I'm going to pull out. 2a squared times 6a will give me 12a cubed. 2a squared times just 1 will give me 2a squared. Remember, the sign that's here is going to get brought down, so we're going to be pulling out a negative, and their GCF is 5. So now I have to ask myself, negative 5 times what will give me the negative 30a, which is 6a, and negative 5 times what will give me my negative 5, also is going to be a positive 1. And these match. The order that you write your binomials in does not matter. I know for the first couple I put the common binomial first, but it can always switch. All right, sometimes we're going to have equations, so I'll give you a second to write down your little subtitle. And number 5 is 9d plus 9 equals d cubed plus d squared. So you'll notice here that they don't equal 0. I have terms on both sides. We want to always have a positive lead coefficient, so we are going to move the 9d and move the 9. Because I don't want to have a negative d cubed if I can avoid it. And in this case, I can't avoid it. It's my choice how I move things around. Go ahead and pause the video and use factoring by grouping yourself, and then come back and we'll solve it. This is what you probably got when you factored by grouping. However, as I hinted at a few minutes ago, this is a dots. So we are not done yet. We have to go ahead and use our 7.7 special products to factor the d squared minus 9 into d plus 3 and d minus 3. That's the a squared minus b squared pattern. And then, of course, the d plus 1 comes down. And now I can use my zero product property from 7.4 to solve all of these. And remember, you can put the 0 at the end if you don't like it. Go ahead and give number 6 a try on your own. All right, here's number 6 all worked out. Again, you had a dots, you had the x squared minus 16, so if you need to highlight that or label that in your notes to really emphasize that you always have to factor completely, go for it. It might not be a bad idea to go back and label that on number 5 also. So that's factoring by grouping when you have 4 terms. What we'll get into next is factoring trinomials with grouping. Factoring trinomials with grouping. So far, you've been using generic rectangles and the diamond problem to factor trinomials, but you can also use grouping. For many of you, after a while, this is going to be your preferred method for factoring instead of drawing the generic rectangle. So go ahead and, this is still in your toolkit on 7.8, go ahead and write down number 7, 12a squared plus 5a minus 2. So what we're going to do is we are going to use the same method that we've done in the past in regards to a diamond problem. So we're going to make our diamond problem, and up here will be negative 24a squared, which was multiplying our a squared term and our c term. That's how I got that. And then on the bottom is going to be 5a. So I'm doing this whole process, but without the generic rectangle. So my two numbers that multiply to give me negative 24a squared, but add to give me 5a are 8a and negative 3a. So what we're going to do is, instead of drawing the generic rectangle, which I'll sketch on the side so you can kind of see the parallel of the process, just really small, I'm going to do this. I would put my 8a and my negative 3a here. I'm actually, in this process, breaking my trinomial into 4 terms. If you look here, I had my 12a squared term, and then I had my negative 2 at the beginning and the end, but then I broke my middle term into 2 separate terms. So what I've been doing this entire time is actually breaking a trinomial into a polynomial with 4 terms. And then what did we do? We looked for greatest common factors. So we've done this before. I'm trying to do this while I talk. Oh, my 3a doesn't want to squeeze in there. You've done this before. You just didn't realize that you were using the same method as grouping. So let me show you what it looks like without the generic rectangle. We have our diamond problem. We're still going to do that. But now, instead of writing it in a generic rectangle, I'm just going to write it in a line. My 12a squared stays the same. Instead of 5a, I'm going to rewrite this as negative 3a and 8a. And then I'm going to bring down my negative 2. So what I just did is I changed my 5a into the 2 numbers that will give me my positive 5a and give me that desired product at the top. So if you're a highlighting kind of kid, those 2 things are connected. And now I have 4 terms, and I can factor by grouping. And what I want to point out here is the values I got in my binomials are the same thing I would get if I used a generic rectangle. So what this is doing is the same exact process, but in a different format, and it is a little bit more time efficient than drawing the generic rectangle. Let's take a look at 8 without drawing the generic rectangle this time. So 8 is 15b squared plus 14b minus 8. I'm just going to do my diamond problem again on the side like we've kind of talked about. My product of my first and last terms is going to be negative 120b squared, and my diamond problem bottom is going to be 14b, that middle term. The numbers that are going to give me those values are 20b and negative 6b. So I'm going to bring down my first term. I'm going to break my middle term into the 20b and the negative 6b. And what I want to point out here is I usually like to put my negative term, if I have one, first, and then my positive, so that when I'm factoring out a GCF, it's positive. It does not matter the order that you put these 2 values in. It is totally up to you. Go ahead and factor this by grouping. I'm going to zoom out so you can see number 9. Give number 9 a try on your own and then come back and check your answers. There's the work for number 9. And then we have 2 more. These have negative lead coefficients, so we need to pay attention to those. Just like we did earlier in the year, we need to take out our negative lead coefficient. So I'm going to take out a -1 because that's all they have in common. Then I'm factoring the trinomial that's left. And I like to put the -1 in front of that x. My numbers are going to be -10x and 9x. And for now, I'm going to ignore the -1 so I don't have to have lots of parentheses. We just can't forget to bring that down at the end. Everything is the same as the last several problems. Don't forget to bring down your GCF. Here's number 11, last question. Go ahead and give that a try on your own and then come back. And there is the work for 11.